Ahead and get started. Uh, this week we're talking about S4. I am not even close to an expert on S4. I've never actually used it. I've not done much at all with object-oriented programming. So I'll maybe start and ask, has anybody on the call used S4 at all or feels like they know something about it?
And I've used bioconductor packages, which you for.
Okay, but not so much creating. So uh, that's okay. I was just going to say if somebody knows a little bit more than I do, feel free to interrupt if I misrepresent something or skip over an important detail or anything like that. I feel like this is probably one where we're all learning together
Yeah.
in this chapter. So um, learning objectives for this chapter. Uh, Hadley lays out basically identify the main components of S4 objects, including the new slot component. Learn about best practices for creating new S4 classes and how to create, modify, and access the objects in those classes. And then I put understand in quotes, multiple inheritance, multiple dispatch, and basically appreciate their risks and complexity. Um, he lays out the not learning objectives, things that this chapter is not going to do is teach us how to most effectively deploy S4 in our own projects or when to use it. He talked about there being no single reference guide out there, and of the reference guides that are out there, the advice often conflicts. So he kind of puts it on us to read other sources, including a lot of Stack Overflow, he said, and figuring out what's best. Um, so the basics, all functions related to S4 live within the methods package. This package is loaded by default in interactive environments, but he notes that it's best practice to call the library explicitly because if your script ever gets run in a non-interactive environment, that library doesn't get loaded by default. And it also shows anybody looking at your code that you are going to explicitly use S4 in what you're doing. The set class function is the primary function for building an S4 class and its slots. And we can see in this basic example that we can call the class person and then set the slots by returning a named character vector uh, with the different classes of those elements. And then we call the new function to actually create an object of that class. So here we're creating a person named John Smith, but we're going to be missing his age. And then we can access these slots that we created with the at sign or the function slot. But he calls out that you shouldn't do this outside of your own methods. Um, and he gets to what you should do instead a little later. Um, so he says you should apply accessor, I assume that's pronounced accessor functions for others to use with your class. And so this is what you should be doing to allow people to read those slots or to modify those slots. And he gives a very basic example of setting two different generics, one for reading and one for writing, and then methods to go along with those that actually end up using the at sign to um, change that slot value. And then he also recommends that if you're working with somebody else's S4 classes, that you should look for accessor functions that they would have written and not just jump into using that at sign to get to the slots. He also points out that the sloop package can be helpful here again to identify S4 objects and their generics. So you can use the O-type function to find out what the type of an object is. And you can also use the F type um, for generic functions to find out what they are. So more detail in classes. The set class has 4 arguments that you should use, and the rest should be ignored. I found it kind of funny in this chapter how often Hadley seems to talk about stuff you should just avoid or ignore. Uh, the primary arguments are the class where you actually set the class name, and he calls out that the convention in S4 is to name your classes with upper camel case. There's the slot argument, which we saw that sets the variables um, and their classes. And then there's a prototype argument that he didn't use in the first example that lists the default value for each slot. And he says that you should always provide a prototype, even though it's technically an optional argument. And finally, the fourth one is the contains argument, which specifies the classes to inherit from. And these S4 objects can inherit from multiple classes.
I think it's really interesting how how do the names slots, prototype, and contains get used? Because it's very different from other S3 or S6 or whatever. I wouldn't think prototype would be that's where you put your default data type.
Yeah, I guess it's like the slot. It made sense to me from a the slots are like shelves or whatever buckets that you're putting the data fields in, and then prototype would be like your kind of like example um, of what one should be. But I guess that they're using that as like default. So if I leave any values out, I could set a default age of 0, right, for somebody instead of making it NAs.
Mm,
His examples, he seems to use NA as the default prototype, but I suppose you could use any value if you had one that's more useful.
makes sense.
So this is the example code he uses to show the use of prototype um, and how to when you build the new person with the now we just provide the name and we don't have to provide an age and we show that it defaults to that NA value. And then his demonstration of using the contains, here we're saying that it's going to be the class employee. It's going to contain all the slots that exist in person. Um, and then the new slot will be one that's called boss, which is of the type, the class person. So the boss will also be a person. Um, and then he shows that the prototype is if you don't pass any values for boss, we'll just create an empty person. So then we get a boss with no name and no age, as well as no name and no age for the actual employee themselves. Um, he cautions about using set class because uh, you can create, if you use set class multiple times and you change elements, you can end up with invalid objects after you've redefined that class. So he just calls out to be careful with that, unlike, I guess, other programming languages where classes tend to be set at compile time and are locked in. You can get yourself in a little trouble if you set the class, create some objects with that class, and then change something about the class later on. You can end up with invalid objects.
Mm.
Uh, Methods, there's a use the is function can help determine the object's classes or test for a specific class. It provides examples of showing, is a person. When we look at the is for a new employee, it's of class employee and class person because of its inheritance that we set. And then we can also test if the object John is of class person and we get true or false. He calls out that user-facing classes should be paired with a helper function to create new objects. So similar to what he told us earlier, not to directly use at and slot. Um, the standard recommendation is to create a helper function to actually create a person instead of directly calling new person. And the conventions are to use the same name as the class. So if the class is person, create the helper function and call it person. And then within your helper function uh, is where you can create the user interface to be friendly to the end user and provide detailed error messages. And when you're at the very end, the last call in that helper function should be to the new. So in his example here, we are making sure that we convert the age to a double, um, and then pass
Mm.
that into the actual new call. So from now on, as an end user, we create a person just by calling the function person. And then we can create a validator to enforce more complex rules around the slot values. So S4 automatically tests for the correct class. So if you say that slot has to have a character, then it will produce an error if you're trying to create an object that isn't using a character. But if you need any more strict or complicated rules, you can use the set validity function to create those tests. And then when we create a new object of that class, that validity is automatically tested. But if we need to explicitly test later, we can call the valid object function. And he notes a caution that uh, validity is automatically checked when you create a new object, but it is not checked if you modify the object. So that's where valid object can come in handy to make sure that if you're making modifications to those slots, that the object that you uh, end up with is still valid.
Mm.
So then he moves into generics and methods. Uh, we can create an S4 generic with the set generic and standard generic functions. It's a pretty simple call. He notes that by convention, the generics should be lower camel case. The classes are upper camel case, and their generics are lower camel case. He also makes an interesting note not to use the braces when you're building this generic function. Apparently, it triggers some expensive special case and should just always be avoided. So he gives the example of essentially don't do this. There's also the signature argument of set generic can be set to help control how dispatch works. It's the only argument he says you should use in the set generic function. Again, he says to ignore all the rest essentially. Um, and this is because without a specific signature, all of the arguments that you set up in that function call are going to be considered during dispatch. And he gives the example of it being helpful if you want to add like a verbose or a quiet or a print type of statement where you don't want the class of that argument to affect how dispatch works. So with the signature here, we're saying only consider the X argument when the function is getting dispatched. And then we define our methods with set method. Again, he says only use the following three arguments and never use any of the other arguments in set method. So the F argument which is essentially the name of the generic, the signature argument, which is the class or classes to use for dispatch. He gets into the multiple in class dispatch later on, and then the actual definition of the function. It gives an example that the show method controls how an object is printed, and it's the most commonly defined S4 method. So I took that as advice that if you create a new class, you should probably also create a show method for your class so that you can print it out in the way that you want. Uh, the first thing you need to do if you're using somebody else's generic is to get the arguments that the function takes. So here, the show generic takes just one argument of object, and then he gives an example of setting up a print show method for our new person class. So it's for the generic show, it's for the class person, and then we pass the function object and print out a nice, pretty multi-line representation. All user accessible slots should be accompanied by a pair of accessors. So this goes back to his advice about not using the at or slot function directly, but creating these accessor functions. He says we should create one for reading the slot. So here we're creating a generic called name to read the name slot of our person class. And then we're creating that method to go along with it, which just calls the um, at name slot. And the other in the pair is for writing. So again, we're creating a new generic that assigns to name. And then here in our method, we're assigning the value with calling the at name slot, and then we're using that valid object um, function to make sure that whatever we set for name is still valid uh, for our new updated object, and then we pass the object at the end. So we can take our John, and he used to be John Smith with an I, and now he's John Smith with a Y and an E. And he says we should always include valid object when we're creating these setter functions, just to make sure that anything we've changed, the object remains valid. So we can use the methods function from the methods package and select methods to investigate available methods for other generics or classes. So if you're working with somebody else's class or generics, we can look at the generics by calling methods. So if we look for the age accessor that we found earlier, we see that it's got a person method, and it gives us advice on how to access help or source code about it. Same thing, we can look at all the methods for a class person that we've created, and we've got two now. We've got one for, or two sets, I should say. We've got one for reading and writing age and reading and writing name, as well as our show. And then finally, you can get the method definition using the select method function, and you call the generic and the class that you want to see the definition for, and it's provided. So, so these tools, I imagine, are useful if you're using other packages that have S4 classes around them to understand what's being done by those methods. So now we get into the fun of method dispatch. S4 dispatch is complicated, is the best way I can sum it up. And this is due to the multiple inheritance that class, an object can have inherit from more than one class. And then there's also multiple dispatch because we can create generics that look at the classes of more than one argument um, to pick their method. So his advice is to keep method dispatch as simple as possible by avoiding multiple inheritance and reserving multiple dispatch for only where it is absolutely necessary. So the rest of this section, he tries to explain it to us, but he's basically cautioning us to, as cool as it sounds, try to avoid it at all costs because it just gets complicated. Um, and he runs the example of using emojis to kind of visualize a dispatch graph. So I pulled in some of his images here. So this shows kind of the inheritance of like the sunglass guy and the cat, and what they come from inherits from a face and a cat face and an actual cat with like the kissy lips or whatever, and then it all goes back to a blank face. So we can kind of use this as our thinking of our complicated multiple inheritance type situations. So he starts us off with single dispatch, which is pretty straightforward. So if we're calling a method on this class of wink with the tongue out, which inherits from just regular wink, which inherits from a blank face, below we can see the graph of how the dispatch would try and work. It would go and look at each of these classes to see if there's a method defined, and when it finds the one where there's a method defined, it would use that. So this is, very similar, I think, to what we saw in S3, right? Pretty
Mm.
straightforward. It just follows the inheritance chain. Um, and he brings up there's, in addition to what formally defined classes, there's these two pseudo classes, any and missing, that you can use to help define some useful behaviors. Any essentially matches any class and is set up so that it's kind of the last of the classes checked. So you can almost kind of try and create a default option, and missing matches whenever one of the arguments is missing, which he said you don't generally need, but it's useful for functions like plus and minus where there's um, you know arguments on each side, right? And you might need to deal with like nothing minus something. So um, multiple inheritance is the tricky part he talks about. Um, So here's this example of multiple inheritance. We have the sunglasses smiley face, which inherits from both sunglasses, and a regular smile, which inherits from a blank face. So if we're trying to dispatch on this call, we look first for, is there one for the sunglass smile face? And then we're also going to branch off in both directions and look for sunglasses and smiley face and blank face eventually. And essentially, he says that in general, the shortest distance as you follow these errors is the class that'll get dispatched. So like if we have the blank face has a method and sunglasses has a method, we would expect for this call to dispatch on sunglasses. But multiple inheritance can lead to ambiguous method dispatch. So in this case, uh, he's showing that there's no method for our sunglasses smile. There's a method for sunglasses. There's a method for smile. Um, so what do we do? They're the same distance apart. What happens? This is what he defines as ambiguous method dispatch. He said when you try and run this, you'll get a warning message from R. It will still resolve to one of these. Um, And he said the rule is supposed to be alphabetical, but in practice it's essentially random. So we really should never rely on ambiguous dispatch. We should always resolve that ambiguity by providing a precise method for this sunglasses and smiley face guy.
Mm.
He goes on again to say, use multiple inheritance with extreme care. He said it's really hard to get uh, no ambiguity, ensure there's always a terminal method, and have a small number of actual methods defined. He gives this example. So this is our, sunglass smiley face, fairly simple graph, it would seem. And he says of all six of these calls here, with the combinations of which ones have methods and which don't, etc., there's only one that's totally free from problems.
Mm.
Then he says, okay, so we've learned about um, multiple inheritance. Now multiple dispatch is less tricky to work with than multiple inheritance, and basically says because there's fewer terminal combinations. And so you can think about the graph and then kind of define the final terminal to be a default behavior and feel more confident in how your dispatch is going to work. Um, so this one, I assume when he's talking terminal, it's kind of the bottom of this graph here, that no matter which direction you go on the graph, eventually it would all lead to the bottom. So you could define a default behavior for that and be confident in how you dispatch, or pick somewhere along the way um, and have more success. And then if you mix multiple dispatch with multiple inheritance, it's complex. So this is the example he gives of two classes, each with multiple inheritance. So the method has two arguments, so it can be multiple dispatch. And then each of those objects and those arguments would be inheriting from multiple classes. So it mixes the multiple inheritance. And you can see the dizzying array of arrows pointing everywhere. I don't even know how you would feel comfortable uh, landing on the correct dispatch in a situation like this. Uh, he closes out this chapter by talking about mixing S4 and S3 classes. Um, he says if you can use S3 classes within your S4 objects or your class definitions, but you have to first register them with this set old class, which can be as simple as just running set old class and the name of the class. But he says it's better to fully specify a new S4 definition for that class. So here, if we were trying to bring in factor, we would want to define an S4 class that mimics factor and then say, okay, if set the old class of factor to this new S4 class of factor. And here again, he gives a caution that I think we've kind of seen throughout the object-oriented programming chapters so far that these definitions should be provided by the creator of the S3 class, and that we shouldn't be trying to build an S4 class on top of somebody else's provided S3 class. Instead, we should go to them as the package maintainer and ask them to add, offer them our code and ask them to add it to be formally part of their package. I think he's kind of seen that. This seems thematically around the same thing with, not accessing slots, look for the accessor functions that people have built. Um, and I think the advice in S3 was like, don't create generics for, classes that you don't control, or you should control the generic or the method. But if you don't, or the class, and if you don't control the generic or the class, you shouldn't be creating stuff around that. And you should work with the actual maintainers. He also notes that if your S4 class will get a special data slot if it's inheriting from an S3 or a base type. So his example here is a ranged number class. It's going to inherit, because we've used the contains, it's going to inherit from the numeric base type. And then we're going to provide slots of min and max. And so then when we look at that object, we also get a data slot, which actually holds our original data. And S3 generics are easily converted to S4 generics. You can simply call set generic on that generic function, and then we can set and then we can see that the default method gets automatically set for us with any. And he says, again, it's okay to convert existing S3 generics to S4, but avoid converting regular plain functions to S4 generics. And that's how the chapter closes out. Anybody else got any good questions or insights we can talk about? Otherwise, I pulled in some of the exercises we can try and go over, if you guys want to do that.
I don't have any unique insights. I'm happy to go through the exercises, just try them out.
Sure. So the first question he brings up in the section is to look at the lubridate period function, that it returns an S4 class. And so he says, well, can we define what slots does it have, what class is each slot, and what are the accessor functions provided? And in his solution, he talks about it has 6 slots for year, month, day, hour, and minute, and it has a data slot, which contains the actual number of seconds for the period. And that all the slots are of type double, and they can be retrieved by identical accessor functions. So there's a year, which will retrieve the year slot from a period, and seconds, which will retrieve the data slot. So we can see an example where he creates a period of 1, 2, 3, 4, 5. And then this should add up to 39 days, 3 hours, and 21 minutes, and 1 second. And sure enough, it does. And when we inspect that, we see the dot data, the year, the month, the days, the hours, and the minutes in their own slots. Says, what other ways can you find help for a method? He says, S says read question mark, and summarizes the details. So besides adding question mark in front of a function call, i.e. question mark method, we can also look for the documentation of the generic name, documentation for methods of the generic name by going methods, question mark, generic name, or documentation for a specific method by using the class name and then a question mark and the method name. So I'll probably handy routes if you're having to work with somebody else's S4 class.
Interesting.
His next exercise is to extend the person class with fields to match utilities person and think about what slots we'll need, what class each slot should have, and what you'll need to check in your validity method. And we start with names and age. And we see that the utility package also has slots given, family, role, email, and comment. That everything but role must be of type character and length 1. And the entry of roles must match one of the following abbreviations. So therefore, role might be of different length than the other slots. And we should add that corresponding constraint to the validator. So the code to do this, we start with our person class. We'll set our types, age, given name, family name, role, email, and comment. And then we set up our prototype. Here he's saying the default is to be missing, an NA for each of those values. And then we'll go on to create our helper functions. So to create a new person, we need the given name and the family name, and everything else can be missing as default. Checks that we're ages are double like we were before. And now we call new to create the new person. And then for our validity for person, we're going to look and check the lengths of the object and say, okay, we're making sure that age, given, family, email, and comment are all one element. And then we're going to check and make sure that our role is one or more of the known roles and nothing else. And finally, we'll check if there's any invalids. So he builds these invalids objects with any of the things that are invalid. We're going to return that information. The next exercise, yes, what happens if you define a new S4 class that doesn't have any slots? And he says essentially it depends on the other arguments. If we inherit from another class, we get the same slots, but something that just happens if we don't inherit from an existing class. He says we get what's called a virtual class, and a virtual class can't be instantiated. So if we set new class type human and we try and say new human with no slots, we get an error. Um, but we can inherit from it apparently. So we can create a virtual class that has no slots and use it to be an inheritance of an additional class. So here he's saying we can create a programmer class that inherits from human, even though we can't actually create any new human objects on their own.
Interesting. So yeah, I wonder what the utility that would have. I mean,
Yeah, I wonder that too, if that's a thing that you would do to kind of set up a multiple inheritance or like a single inheritance type thing for your dispatch. Um, I guess you could do it as a label in a sense for, you've got a class of programmer, but you might also have a class of like accountant, and they're both humans, but you don't really need any details beyond the fact that they're human classes. So they end up inheriting from the same class human, but you don't have to actually store any details in that.
interesting.
But of course, not in the learning objectives is how to apply this
Yeah.
effectively.
I can maybe see like you can, make a method for the programmer, but you don't have any like different slots for the programmer than what human would have. Because maybe you want to like show things about a programmer a little bit differently than if it was just a human.
Yeah, yeah, exactly.
That just
A
depends on it.
little more
Um,
technical detail in printing out the programmer class than just the human class.
Yeah, pretty funny. Yeah, like if you want to show like a different emoji.
Yeah.
Funny.
The next question he asks, imagine you're going to re-implement factors dates and data frames in S4, sketch out the set class calls that you think would use to define the classes, and think about appropriate slots and prototypes. Um,
Mm,
so another kind of heavy exercise that he gets into, and he says we need one slot for the data and one slot per attribute. And that keep in mind that inheritance matters for ordered factors and dates. And then for data frames, special checks like equal length of the underlying list element should be done with the validator. Um, and then he kind of goes to the example of, we see our factor that we set up before, um, introducing the ordered slot and a default prototype here. The default is he's not using the NAs like he's done in the other example, but here's the prototype saying that if we don't pass anything, it's going to be an empty integer and an empty character and a false for ordered.
mm, mm,
And then his example of a date two, it's just going to be an integer for the data. And the prototype again is an empty integer vector.
mm,
And then for data frame, our data is going to be a type of list, as we know, because a data frame is nothing but a list, bunch of lists. Uh, and then our row names will be a character vector, and the prototype will be an empty list, and again, an empty character vector. Which is kind of like this really highlights to me the simplicity really of the actual objects, and all the fun stuff that we enjoy with like data frame, and dates is really in the methods, right? Um, for printing and manipulating them. The next exercise, he says to add an age accessor for the persons class. This is kind of an interesting one that he put in the exercises since he essentially gave the answer in the in the basics chapter. Um, but we can just look at it again of setting the generic for age, and then the method to read age is pretty straightforward. And then we set a generic for assigning or setting the age. And again, we set it into the slot. The pattern is check the validity of the object after you've set the new value and then return the object at the end.
I definitely see the parallels with S3. But here's is more verbose, like you're saying set generic or set method, whereas with S3 you have like print and then you use method, print. And then you make like print dot character or print dot data frame.
Yeah.
You're not like saying it. Really, that's what you're doing. You're making the generic first, and then you're making methods where you're indicating your methods with that period.
Yeah. And it's a little more specific and verbose. You don't get into confusions if you create a generic with a period or some other function with a
Mhm.
period. Like it is very clear that this method is supposed to be for calling this on this class, and there's less confusion there. Yeah, I looking at this S4, it kind of makes me feel like there seems to be a lot of work that you need to do if you're creating an S4 class uh, to be a good practitioner for others. You have to you create the class, and then you have to create a function for creating new objects in the class. You have to create a function or a set of generics for each slot to read and write. And then you probably also need to do a show method so that you can print out your class nicely. And that's like the bare minimum. I feel like he's kind of directing us to when you create a new class. So um, lots more functions that you need to work with. So then he asks, in the definition of the generic, why is it necessary to repeat the name of the generic twice? And his answer is that within such generic, the first argument is needed as the name of the generic. Then the name also explicitly incorporates method dispatch via standard generic within its body. So he says this behavior is similar to the use method function in S3 that we were just talking about. Then he asks, why does show method defined in section 15.4.3 use is object and brackets? And then he says, try printing the employee subclass. And the answer is that is object returns the class of the object, and is object also contains the superclasses for subclasses like employee. So in order for it to always return the most specific class, um, we needed to just return the first element. So essentially, he's saying that is object will list all of the inherited classes. And so if you only want to know about the most specific um, class, then you need to say, I just want the first element in that return. So what happens if you define a method with different argument names to the generic? And he runs through the generic this example of creating a class of dot person instead of person. And then we can say, look at the argument supplied by show. We know it's just object. So we would usually use this when creating a method correctly. Um, so we'll receive a warning if we use something else, but it'll still work based on position. And we'll get an error if we add more arguments to our function than exist in the generic. So we get other at, so the idea is to, if you want to open up your generic to having other arguments in the methods, you can use the triple dots.
Mm.
Then he gets into the fun of drawing method graphs for various calls. Um, so we can look at this one. So uh, this one, I think, is another case of multiple inheritance, multiple dispatch. And he says, look at the graph and repeat after me. I will keep my class structure simple and use multiple inheritance sparingly.
Huh.
So yeah, you can see this one is so it's very gnarly.
Now I'm interested to see like which bioconductor class uses multiple inheritance the most.
Yeah, that'd be interesting to see like how much is this utilized in the wild.
Yeah.
And then he says, draw another method graph for this combination of emojis. And he says that the method graph below looks simpler than the one above. Relatively speaking, multiple dispatch seems to introduce less complexity than multiple inheritance, but still use it for care. So he shows, okay, so here's our inheritance. And because it's much fewer um,
Mm.
levels of inheritance, even though we've got an extra dispatch call, there's fewer nodes in our graph.
Mm.
So here he's saying, consider the last example. What happens if you define a method for all terminal classes? Why does method dispatch not save us much work here? So basically it says we'll introduce ambiguity since one class has distance 2 to all terminal nodes and the other 4 have distance 1 to 2 of the terminal nodes. So to resolve this ambiguity, we have to define 5 more methods, one per class combination. So basically relying on method dispatch to pick the correct method in a multiple dispatch, multiple inheritance situation uh, is unreliable. And so to know we have the right answer or deal with that ambiguity, we essentially just have to create more methods. So at that point, dispatch isn't doing us any favors because of how many different methods we've had to create to make sure that whatever combination is called, we get the right or predictable method. And he asked, what would a full set old class definition look like for an ordered factor? He's kind of already done this again. He's asking us a question on something he showed us a little earlier. Um, but we can say, okay, set old class factor. So here we're converting original factor, and then we're creating ordered factor, which inherits from factor, and adds slots for levels and ordered, and then has the prototype, right, of integer, empty integer levels and ordered. And then we can set the old S3 ordered class to be the new S4 ordered factor. And then if we create an ordered factor as an example, and we can see we have our dot data slot again because we're inheriting from a S3 class, and then we have our levels and our ordered. Yeah.
Mm.
And then he goes on to define a length method for the person class. So he says we're going to keep it simple by just returning a default value when the length method is called. So um, the method he says can be defined either as an S3 or S4 method. So, um, the the length.person function, 180 centimeters, or we can use set method length person function. So the mix of S3 or S4 type um, method creation, even on an S4 class. And that's all. That's it for the exercises. Does anybody feel more comfortable with S4 objects now?
Stand more of it, but now I'm thinking, a lot of pitfalls.
Yeah, it definitely feels like something that you really have to think through to do it right. Um, and that there's kind of like you got to stay in a narrow lane to not get too off course. S3s definitely seem like more fast and loose and a little more fun to rock and roll with. But I can understand like why S4 was created to lock down some more of that formality. So I'll ask Nick, you said you work with bioconductor packages on occasion. Can you like give some examples of like the type of things that they use S4 objects to represent that you've encountered?
Um, yeah. So they represent. So it's really a lot of genomic information. By genomics, I mean like DNA, RNA, and protein measurements. If you just think about DNA, for example, DNA, it's like a string of letters, like four unique letters, it's a string, and so it could have a length, a start and end, and a lot of genomic analysis includes like intersecting these different strings together. And so there's an SR class, I think that, does this arithmetic of intersecting or just arithmetic operations with strings, pretty much. And so there's a class for representing these strings, and there's a class representing intervals. So not just the string, but also the length and the start and end and so on. Um, and then there's classes for doing some other type of analysis. And so because like this is a pattern of inheritance, where you wanna, show like a DNA string a certain way, even though it's within a interval class, for example. Uh, there's also other classes for basic data management. Because if you heard of like the omics, not just genomics, but these are other data types and they each require different storage patterns and techniques. And people want to do analysis on many data types, and so different data types may have their own class. Or there's one class that allows for putting different data types, not just in different slots, but maybe using different methods, and so that's basically how they're used and why they would be used. Um, yeah.
Yeah, no, that helps actually. That helps a lot. It makes sense that like stuff like DNA sequences, which is like a very particular type of data that's not easily represented by, a base type, and it's going to have very specific ways that you have to operate on it.
Yeah.
Like you said, like if you're adding things together and you have to make sure that there's certain,
Mm.
validity after you do the operations, that makes a
Yeah.
lot of sense where S4 probably would shine in that space to make sure that, you don't screw up your object when you do a process on it.
Yeah, and I think validity is really important. I haven't checked the particular validity checks, but I can see like there's a lot of routine tasks that are done in a particular procedure by a lot of different people that do like the same sorts of experiments, and making sure that there's validity checks, really helps with like making the science pretty much reproducible, and you can verify that these things are being analyzed in like a consistent way, and there's no like tomfoolery.
Yeah, yeah, cool. Thanks,
Yeah.
Nick.
Yeah.
Anybody else got any other questions or topics in the last minute here? No? All right. Thanks for joining. I think we'll be on next week for, is it R6 or do we jump into S7 first?
Yeah, 7, I think.
S7, the combination of 3 plus 4. I'm
Mhm.
interested now to see if S7 is going to be any friendlier than S4.
Yeah, me too.
All right. Everybody have a good week until then.
All right, we can say and, right?
Yeah, I think it's stop